Wanted to get started with a couple quick polls, and hopefully people will participate in them. First poll up on your screen now. If you could take just a minute or two to respond to that. Is you guys in the room can't respond to it, but the first poll is when doing stormwater management, do you dislike coverage analysis? You know, tracing around the different areas in doing stormwater. Just in this room.
I dislike it.
Charles dislikes it. Brand, Bob dislikes it. So I'm talking about determining your drainage areas,
Some people like it.
and then you have to figure out how much of that's impervious, and then you also have to figure out how much of that is in different soil types. So it's a tedious task to do. Surprisingly, we got 77% of the people voted here. And share results. Surprisingly, half of you like it and half of you dislike it. Well, this method I'm about to show you today deals in a great part with disliking doing that monotonous task. I think it's very monotonous to trace all these areas, and it takes a lot of time if you're doing it by hand especially, but even in AutoCAD to figure out the area of a drainage area and then break it down per cover and soil type. So we're going to show you some techniques to make that a lot quicker. Another poll I'm going to launch here, and be honest on this one. Have you ever been on an HRG project that went over budget? Let's see a hand. Come on, show of hands in this room. Brian Riesinger, no? Yeah, whatever. Yeah. All right, so let me 69% voted there. We get a couple more votes and close that poll. So as you can see, from this room you had 100% of the people, or let's say 95% of the people except for Riesinger. And majority of people have been on projects that went over budget. So that can happen a number of different ways. But I think a large part of it here at HRG is we need to do stuff as most efficiently as possible. What I notice happens all the time is we estimate what we think it should take, and we're either conservative or it takes longer, than we think when we do our proposal. A lot of other times is the client, we send a proposal for 80 grand and they come back and they say, well, we'll give you the project for 60, and we don't cut scope. Well, that means we need to really do this efficiently. So hopefully with some of these techniques, we're feeling that. That's the market right there. That's that market push that's affecting us. So, doing things efficiently is impacting us already. Let me close that poll. All right. So let me just go through this. How do we streamline stormwater management? Well, we're going to use the best tools at our disposal. We're going to invest some upfront time for quick updates. A lot of these projects, stormwater is an iterative process. You take a first whack at it, first guess, get a basic pond size that tells you where you're locating a pond's a good location. But as you don't have the site graded yet typically, and then you start grading it in, you have to iterate 2 or 3 times. Usually I iterate a project at least twice before I get the actual report out the door. We're going to optimize data transfer, and we're going to round trip data. So I'm not going to just talk about like these concepts of how to do this. I'm going to show you how and tools that we have to do this. What are we going to make easier through today's presentation? We're going to get our curve numbers, we're going to make that a whole lot easier. Inputting our drainage areas into HydroCAD, and we'll talk about that software, HydroFlow. Getting our MPDS volumes, filling out the MPDS worksheets. We're going to show you some tools to make that a whole lot easier, and doing the treatment train analysis. Unfortunately, we're not going to be able to cover this treatment train, but I will show you a spreadsheet that you can take a look at if you need to do that. This is when you can infiltrate, use the treatment train. We're going to import pipe runs into HydroFlow, and we're going to round trip that design between HydroFlow and Civil 3D, something you could do one time before, but with some worksheets we have now, you can do that as many times as you want. if you do have questions, I'll accept questions at the end here. I'm not going to be able to do those as we start or as I go. I'm not going to be able to address questions, but I'll pause at certain spots to look on the questions panel to see if people have questions. If you are on the phone, I'll unmute all attendees on the phone here. Let me look real quick. Attendees list. Okay, so I got Dwight on, or State College unmuted. Jason, I'm going to unmute you guys in Lancaster because you're on the phone. And Nick Argot. So you guys can mute your phones if you don't want to hear anything, but you'll be able to ask questions. So feel free, for those on the phone, to ask questions as we go. But the rest, I'll be able to only look at that questions panel on the software every now and then. What we're going to get from a bonus from this is also from how we're determining these areas and everything, we're going to have be able to quickly determine lot impervious coverage. This doesn't really have to do with stormwater, but more for zoning. We'll have areas to apply rendering materials quickly, so that more has to do with some fancy rendering, not really stormwater, but you'll have that utility. And you'll have areas to apply surface smoothing, which is another thing for grading. But you can see you get a lot of infrastructure to do these different tasks. The tools we have are AutoCAD, of course. We're going to use HydroCAD today. We're going to use HydroFlow. We have HydroFlow Express storm sewers. We have HydroFlow Express and HydroGraph. And then we're going to use the HRG data flow worksheets. So that's really the introduction here. How these softwares work out is that if you were in the land development group at HRG, land development as a group purchased HydroCAD. I think a lot of people have that. Other service groups can. It's pretty inexpensive, but that's what we're going to focus on for management. You can see on the PowerPoint here, you know, this software, stormwater management, this is management, conveyance, this is sort of culverts, and so on and so forth. What we're really going to focus on today are going to be AutoCAD, HydroCAD, HydroFlow, storm sewers, and the HRG data flow worksheets. So how is this going to work is we're going to determine our areas using AutoCAD or Civil 3D. We're going to use the HRG worksheets, again, the key part here, and we're going to push that data directly into HydroCAD and HydroFlow storm sewers. No manual editing or manual data entry at all. Another thing we're going to end here with is we're going to take pipe data from Civil 3D as laid out, and the software sort of designed it for you a little bit. And we could always take that and push that into HydroFlow, design it once and take it back, but we can only do that one time. With these, thanks to Brandon Harner and these HRG, everybody, thank Brandon Harner, round of applause. We did do a lot of work on these, and most of this is all possible through his efforts. So if you see him around, if you're in a branch office, just remember, give him the thanks on this one. But using these HRG data flow worksheets, we're going to be able to round trip that data as many times as we want. All right, so that gives you a basic outline of what we're going to talk about. Let's get into it here. So I know I'm going to bring up this this black screen of AutoCAD, and I know we have, you know, some engineers in different branch offices or whatnot that say, well, I don't do AutoCAD. Well, this is a tool to help us streamline stormwater management. So use it, leverage it to your advantage. You know, it's I'm sure you're probably using it now to perimeter areas or trace around areas. Well, if you're using it to trace around areas, you can just do the steps I'm going to show here and save a lot of time. What we're going to first use to get these area determinations is a thing called topologies. So, you know, I only have an hour here, so I had to go through and set a lot of this up for myself. But I'm going to go through showing you how to do one topology. And then even if you've seen this before, we streamlined a lot of the, because this isn't really new. We've been using this in our group here for what, a year, 2 years? No. Year and a half topologies. But we've really streamlined, through Brandon organizing it and doing some worksheets, we've really streamlined the process of doing the overlays and whatnot. So I'll show you some of the steps here, and I think you'll be able to pick out the rest. For things I didn't cover, you'll be able to refer back to this video to refresh yourself. And there's also, if you go to our intranet site, Engineering CAD Resources, and you go to these 2007 HRG CAD training videos, January, February, and March, we went into great detail. This is when it really first started, so since 2007, of using topology. So you can refer to those, and that will give you the very in-depth if you want to review that and go back. Okay, so what is a topology? Well, we basically need three things to do our cover analysis, right? You need soil type, you need impervious coverage, and you need your drainage area, right? So there's three components of every drainage area. What, type soil, what's the cover type, and then which drainage area is it in. So I took this site and have some things set up. Let me simplify it here and unload some things. And I already determined my my drainage areas, and I already did my pre-cover. So let's look at the pre-cover condition here. So this is the pre-development for the site. We're going to develop this area right here, and right now it's meadow. And you can see this is basically what you're looking at as a topology. That topology lets the computer know what areas are what. And with that, you can overlay all these things and get a curve number fairly quickly. So let me create a topology for the post drainage areas, and then through that, hopefully you'll see the rest of the topologies you create the same way. It's just different data. You'd be doing cover or soils versus drainage areas. So I do have some of this set up, like I said. Let me go back here, turn back on my post drainage areas. To get started with this for any project, I would recommend, and you can use this in Land, Desktop, or in Civil 3D, starting a drawing with this HRG topology template. I'm sure people have seen where they start templates. There's an HRG topology template. You'd start a drawing with that. It's basically blank. The only things that are in it is the layer convention up here at the top, so you'd have to use these layers, and some naming for the object data sets, which I'll show here in just a minute. So after you do that, I'm going to draw in my drainage areas. If you look at this drainage area line here, there's nothing special about it. It's just a normal polyline. You can see up here, it's just a polyline. So hopefully we're doing that now. You're determining your drainage areas through polylines, right? The only difference is I'm going to take that polyline. I don't need to draw a closed-in polyline. I can just draw, where they connect. So there's only one line here between drainage area I6 and drainage area I6A. It's not like they're double-closed polylines. So get all those drawn in. And then this is just a normal piece of text. It's important that you don't use mtext here. And no, we should use mtext for everything else, but this, just use plain old AutoCAD text or dtext. Don't use mtext, and you'll be in good shape. And just place that text in the center of these drainage areas. It doesn't have to be center, just as long as it's enclosed in here somewhere. The polylines, hopefully you'll be able to, hopefully this is intuitive. They would go on my drainage area post layer, and the text in the center that just delineates the drainage area would be, or what type of drainage area it is, would be on this post drainage area centroid layer. Okay? So that's it. Hopefully that sits well with everybody. You know what I'm talking about there, just outlining drainage areas. From there, I'm going to isolate this text that we drew in, and I need to add some object data to this. So what is object data? Well, object data is essentially going to add a field to the text. So if you click on any piece of text in AutoCAD and you go down here in the properties dialog and you scroll down, you can see there's all kinds of data associated with this. There's 3D visual rendering styles and text properties and geometry and so on and so forth. Well, we're going to add another piece of data to this text down here, sort of a custom piece of data. That's really what object data is. Okay? To do that, just follow the steps. It's going to go down here to my map pull down. I'm going to go over to open up database, hit generate links. I don't know why it's called that. It should be called attach object data, but Generate links is what it's called. I'm going to change this to text, create object data record, and I'm going to select the post DA drainage area. So how do you know which one to select here? Well, I'm going to highlight some new things on the R drive for everybody to use. If you go under R, templates, and under there's topologies, there's a Excel file that you can open that outlines what everything needs to be named and how to use it. So I have a PDF of that. I'm gonna go to that here real quick. But you can open that Excel file and print it out. It's what I recommend. So I already did that. I have a PDF. So opening in that PDF, you can see, I'm doing post-development. I'm going to make a topology for this post-development. You can see the two layers I'm dealing with, putting my post-development drainage areas on and the area delineator, okay? And then the object data that I want to use, object data table, is post-DA, okay? So you use this Excel sheet as a guide to getting this all done. Go ahead and select that, hit OK. I'm just going to hit S for select and highlight all the text and hit enter. Once I do that, if I now grab one of these pieces of text and I look, now there's a new piece of data associated with that text. And that generate links button essentially took the text contents from up here, made this new data table, and populated it with the same description. So that text that you would make, that would be your drainage maps. So point of interest A, inlet 1, inlet 2, pond 1, and that's how you'd make that up and start. Okay? From here, I'm ready to make my topology. One thing you can use to help yourself making these topologies is that this line work needs to be very clean. And to do that, we have a tool, it's called Map Cleanup, that will clean this up. For example, if you can see in here, if I zoom in, see how this line sort of overshoots the end? They don't really touch the end here. Or that this line is not joined to this one. Those need to be joined. Or, this one is joined, all the way through, even though there's a break here. For this to be made into a topology accurately, each line needs to be joined until it intersects another line. So this is all one segment, and then it breaks right here. This is all another segment, and it breaks, and so on and so forth. Does that make any sense? These line segments that are linked together here are called links. When links encapsulate a piece of text that has object data, that's called a centroid. That's why, so this is now our centroid, okay? That's where you see some of these terminologies up here. So these are just quote, quote terminologies keep in the back of your head. So to clean this stuff up, this one needs to be extended to touch in here, and so on and so forth. We can use a piece or a command called map clean, okay? Again, here's a streamlining piece. We're going to just hit load, go to R, templates, topologies, and load in this create topology 1 foot tolerance. So when I say 1 foot tolerance, your line work needs to be at least within a foot of each other. It can't be really super sloppy. It needs to be somewhat, within a foot. Hit open. Select objects. I'm just going to pick the layer. Go up here. Select the drainage area post layer. Hit finished. And you can see down here, it found some errors and fixed them and created some objects. So you need to keep doing that map clean until this reads 000. So let's do it again. All right, so all my line work's cleaned up. So you just need to keep running that command. And you just type map clean, hit finish, type map clean, hit finish, type map clean, hit finish until that reads 000. Okay? Once it's all cleaned up, you can see now this is joined together. This no longer overshoots, things like that. I'm going to create a topology of this. To create your topologies, type in map W space on. It brings up the map toolbar. Go to topologies. You can see I have some created here already. I had to self-populate this a little bit. I don't have time to go through from stage one. I'm going to hit create. In here, I need to come up with a topology name. What do I use? Well, I refer back to my little sheet here. This is important that I follow these naming conventions. If I don't, none of this is really going to work. Okay? So I'm going to call that topology post DA. My links are the green lines. I'm going to go up, select that layer, drain post, 00 drain post. I can skip all this, just come down to centroids. I'm going to select that layer where all the centroids reside, which is these pieces of text. Hit OK. Go to create new centroids, uncheck that, and hit finished. That's it. Okay. Brandon's saying you can save some time if you just isolate the links and centroids. You can just hit finished, and it will go through without clicking those layers. So that's another way to save some steps there. Okay, that's it. Now I have my topology. So this drainage area map is now smart, quote, quote, smart. If I right-click on it and hit show, AutoCAD is aware of the area of all these different drainage points. So if I click on I6A, go to my properties dialog, there's even more more data associated with it. You can see the area that that drains to inlet 6 is 28,379 square feet. Any questions on that? That same thing I did, creating a topology. You have to do that for soils, and you have to do that for cover and your drainage areas. You have to make 3 topologies. Okay? Soils, area, and cover. After that's the hard part. After that, the rest is really automated from this point forward. It's just copying and pasting some stuff here and there. Okay? See if there's any questions on the box here. Okay, I don't have any questions there. All right. I'm going to keep going. Okay, so from this point, here's where we really get some streamlining. We're going to exit out of AutoCAD here pretty soon. We have to do some our overlay analysis. I created the soils in a separate drawing, so I'm going to load that drawing up here. So now I see my soils topology. I'm going to load that topology. Right-click on it, hit load. Let's load that up. And I'm going to load my pre-cover and my post cover. Okay? My pre, as you can see, if I right-click on that topology and hit show geometry, you'll see the pre. Looks like that. No development in this area shown yet. And my post, the topology I did for that is just my developed area. Okay? Does that make sense? Drainage, you have to, this is all going to be grass. Then I had to put in all the little homes, so on and so forth. And we'll touch back on that, but I do got to get moving along. First, I need to overlay. I need to really have a coverage that takes my pre and then puts my new impervious and grass area on top of it, right? Because that's ultimately what the site's going to be, because I'm doing post right now. I'm not doing, the pre's already done. To do that, I'm just going to right-click on my pre here, or to know how to do that, to even start. I'm going to go look at my topology template here, and like I said, we're starting to get into the topology combinations or overlays, and I really want to get a final post-development coverage, because some of our drainage areas might go off-site, right? So you have like pre in those areas, but when they get on-site, you have post cover, right? So you need one that has both, sort of your final design. So how do I know how to overlay this? Well, I'm just going to right-click on my pre-CV. I'm going to load up my overlay template 01 and make sure it's targeting the post-CV. So let's just show this in action. Right-click on pre, hit analysis, go to overlay, hit load. Again, our AutoCAD templates topologies. Everything's there. Hit 1. Hit open. You do have to check one thing. Make sure notice this is not targeted to the right. It doesn't always select the right topology to overlay against. So you always have to check this. How do I know which one this needs to be? Anybody? I'm looking back here. It always has to be the second line. You're right-clicking on the first one, pasting on the second one. Just hit finished. Computer chugs, and now I have it made a new topology that you can see is the combination of my pre and my post. See that? So that's how the site's going to look when it's all developed. Okay? So now I want to overlay my drainage areas, my post drainage areas with my soil. So let's just turn this off for a minute. I'm going to right-click on my drainage areas. Analysis, overlay. I'm going to hit load. I'll refer to my handy-dandy guide here. This is pre, don't need to do pre, we're doing post right now. Okay, pre-drainage areas over soils. Okay, right-click on post, load for, target soils. Got it. Right-clicked on for, or right-clicked on post. Upload template 4. Make sure it's targeting soils. Hit finish. Okay, there's my drainage area breakdown from soils to covers. You can see I have soils coming up through here. I changed the drainage characteristics. You have different soils groups. All right, well, here's the big one. Now I'm going to right-click on post drainage area soils, analysis, overlay again. Going to upload 5. How do I know that? I refer to that sheet. Make sure it's targeting post CD complete. Again, that sheet shows you this. So I have to keep everybody following me here. I know how to do this because this is telling me right here. Okay? Hit finished. If you get messages, just close them. Don't worry about the messages. So as you can see, the work I would have had to do this by hand is quite extensive to do it right. That's the other part, to do it right. I used to work at a shop, they'd say this, and they'd look at that, and they'd put their thumb up and say, it's about 50% impervious. That's not doing it right. Our clients are we're paying them $110 an hour for me to work on their project. At least I can give them the right answer. But I would have had to trace out, this is impervious. It's only half this building, so half this building's in here and half's down here, and it's just a little bit of this shed. And, I know some of the things like this are a little bit gnats kind of stuff will not even show up. But in general, it's a lot of work. Look at all these different drainage areas I'd have to perimeter around or trace around to get for my cover. If I wasn't presenting this, I could have did this probably in 3 minutes. Because once you click through it a couple times, especially with these overlay templates.
Now you have to draw the lines around all the impervious buildings and everything, right?
Yeah, but don't you have that already? Didn't somebody already draw your layout in CAD that you can copy, paste into this file, run the map clean on, put the eyes for in the buildings for impervious, okay. Do the generate links, and you're done. It's not that much. Same thing for existing. Oh, geez, all the existing tree row. Yeah, but there are tree rows and buildings in CAD and roads. Go into your existing conditions base file, copy out all the line work, put it on one layer, paste it, run the map clean. You're going to have to clean it up. Put the eyes in the paste. The CV, the meadows for where meadow is, and it doesn't take that much time.
The stormwater design takes 2 hours now.
Stormwater design does not take 2 hours now, but this would take days.
Yeah.
Now takes 15 minutes. So, and wait till I show you some of the next pieces.
And that's the benefit to setting up our drawings the way we do now as opposed to the way we used to.
Yeah, Steve was saying that's the benefit, setting them up this way and opposed to the way we were doing it before. But yeah, you're investing, guaranteed you are making upfront investments to make quick updates. We're investing upfront time, which is still not that much. And from this upfront investment, and we're doing the same thing all the time, we grade using 3D polylines, right, in Land Desktop and now in Civil 3D Feature Lines to make our surfaces pretty accurate. Because then our profiles are accurate, our cross sections are accurate, our pipes are set right from the top surface, right? So we invested all that upfront time to get a huge benefit on the backside. It's the same thing. Let me just keep going. If you want to see some of the little characteristics, these little dots here, if you type in PD mode, set that to 3, those dots turn into X's, and you can click on one of those, and then you can see where that area falls. You can see that drainage area drains to I4. It's soil type BKB, and it's in post cover, and the abbreviation we use there is I for impervious. If I go outside of our post area and look at one of those, that area is called bypass 1, BK1, and that's really it. Okay? Yeah, I do. I have the soils on yet. That's why it doesn't. I have to click on this one. Yeah, there you go.
You have a cheat sheet for the cover codes that we should use?
I'll show you where you're going to get those cover codes. You're going to get them right from the Excel file. Okay? So you're thinking, well, how do you know if to call it M or I and all this stuff for cover? Because it's important. I'll show you here just in a second. See if there's any other quick questions. Do we have soils data for all of the counties in Pennsylvania? It is available throughout the entire state on the PASDA website. You can be downloaded. There's a bunch of people that know how to do that. I know Dwight knows how in State College. Like Rob Rowe or Howard Hodder can help with that too. They know where to get it. I know how to get it if you need a certain county. It's all available. We only have downloaded what we need though. So Dauphin County is probably downloaded because we've used that a bunch of times. Cumberland, I know Center County, I think, is down. I'm sure Center County is downloaded because Rob's in that area. But, if you're working up in some county up in, if you're working in Elk County, maybe that's not downloaded yet because there's not all that much going on. So you sort of download it as you need it. But, yes, it's available. So that line work for all the soils, done. You just bring it in, put the little soil cover types in there, or the soil names, and go from there. So, yes. All right, that's the only question I got on there so far. Okay, so the next point is we're done with AutoCAD. Okay, we did our cover analysis. We need to get this data out. We're going to go up to Query and Run External Query. Okay, Query and Run External Query. Again, we're going to go to R. Templates, topologies, and you want to run the query based on what topology you want to get out. So this post DA soil CV, that's the final one that I created that overlays the 3 things, right? Drainage area, soils, and cover. So I want to get that data out of AutoCAD because I need to now go to Excel, and this is where we're going to use those sheets. So I'm going to use this post DA soils and CV query. Hit OK, and the computer will flash for a little bit. Still flashing for me, if you can see up here. And it's pooping all that data out onto XShare. This is a technical term. It's a Berks County thing. So right here you can see, we've been using this today. Some people have. That made a text file on the XShare. Now, do keep in mind that if multiple people in offices are doing this at the exact same time, you need to go get your text, you click it, go get your text file, cut it, and paste it in your project. Don't just leave it on XShare. Because if Brandon were to be at his desk right now and he clicked Run External Query, it would overwrite mine. Got it? So run it, go get it. We needed to dump it to a universal location for it to work. It's just how it is. But do watch out for that. You'll know. You'd be like, this isn't not my site. Why is this so small? So you would see right up front. So I'm going to take that file and I'm going to cut it and paste it into my my Lunch and Learn presentations folder I have here. The next piece of this is I'm going to go back into, we're essentially done with AutoCAD. I'm going to go back to our templates topologies. Everybody getting the idea? Our templates topologies has everything in it. It's real simple. I need this worksheet, this HydroFlow and HydroCAD compress. Copy that and paste it into your project. I've already done that. Here it is. Just copy it out of there, paste it in your project. Open that up. When it opens, you must enable macros for this to work. If you don't get the message, your security level could be set too high, but you need to have macros enabled for this to run. I have done this already. When you bring this in, these are going to be blank, and I'll cover those in a second. Here's the, you were talking about how do we know what the abbreviations for the covers are? It's right here. So how did I know to use M for Meadow? Well, that's what's plugged into this sheet. So it just corresponds to what's ever on the sheet. If you want to make up drain or cover types, maybe it doesn't have everything you need. This is a standard SCS list. You can enter in whatever abbreviation you want, what it needs, and then the different, what it means, and then the different curve number. Same thing for rational. So you're all saying, I don't use SCS, I just use rational. Well, there you go. Here's rational. Does that make sense? So you might need to refer to this up front. Okay? You can use it, again, you can use whatever you want, but it needs to match in both spots. Like your cover analysis needs to have the right abbreviation to match this sheet.
Why wouldn't we just make that standard?
It is. Right there's the sheet.
Required.
Well, it's required. Use it. But if you need additional one, you can enter custom data here. Another thing you do need to enter in this sheet before you get started is my soil type. So I need to enter in my BKB, my BKC. These are the soils I have for this area. And initially you'd think, well, why can't we do that for the whole state? Isn't BKC always soils group C? No, it's not. Unfortunately, I tried that. We tried going down that path to make this master file. But BKC is not always hydraulic soils group C in every county. Crazy, isn't it? So you got to enter that in. From there, that's it. I'm going to hit open. Find that file that I created, that text file. I'm going to open it in Excel. So it's going to ask me, what kind of file is it, comma delineated. Just going to go to next. It's separated by commas. So check comma delineated, hit finished. And now I have two files open. What I'm going to need to do is paste. You can see this is sort of the control panel where we're going to push data out. This is where we need to enter some data. And this is where our drainage areas are going to be inserted. So I'm going to insert my point of interest, my cover type, my soil type, my area ID, and my area. So that's 5 columns. But you can see on this Excel sheet, I actually have 6 columns. So I need to combine these 2 columns, right? And the reason there's 2 is because this is pre and this is post, all right? So to do that, that's simple. Just highlight all the columns, hit sort, change this to B, change this to C for column B and C, hit OK. I'm going to copy the, it basically puts B all the way at the top. Copy that content, paste it into C, and delete column B. Okay, a little bit of Excel, just get the content across from B to C. You can do it, but if you sort it, if you catch that, Bill, you're looking like, holy smokes, that is the smoothest thing since silk. You can sort columns by selecting them all and go up to data and sort. If I sort B and C, that makes sure that it lines up data in both columns. Try it.
Yeah.
Go back to the video. You see what I did. All right. All right, so from this point, I'm just going to copy all this data. So I'm going to go down to the bottom here. Control, Shift, I'm going to, you can select the data. I'm sure you guys know how to select data in Excel. Right click on it, hit copy. I'm going to paste it into this Excel file. All I need to do now is come into here, type in a path for where I want my HydroCAD file to be created. Hit Update HydroCAD File. Now you're going to get this message come up because it's going to create a node for every, it's going to create a HydroCAD node for every drainage area for me automatically. So it would be nice to say, Brandon, if this is this the first time you're running this? Yes or no? And if you say no, it would ask you or show you these. But if you hit yes, it would just do it. But right now, how it works is you have to click yes for each one of these. So it doesn't take all that long. If you have a huge site, and you don't have to do this if you're updating a HydroCAD file. It's only the first time you're making it.
We could add me to do that part.
Yeah, Brandon will do it. So it made that HydroCAD file. And it's going to close, it's going to save and close that worksheet. And you can see right now I have this HydroCAD file. I'm going to open that up in HydroCAD, and I have the drainage. It doesn't know where to put them, so it just puts them on top of each other, so I can drag these out. It takes a little bit of time to do this, but that's nothing. And what did I get out of this? So you can see I keep dragging them out. There's a couple of them there. If I edit these and click on them here and go to areas, this is already filled out. All my curve numbers, all my drainage areas, and HydroCAD does the weighted curve number for me. Okay? It's already done. So I'm not going to set this model up. You still have to do that. This is where Stormwater still takes time. You have to do the design, right? So I'm going to close that and go to design here. Did I have one? There. I already have the design done. Post EA. And, I brought in a nice little image, and I took all the HydroCAD nodes, and I pointed them to go to ponds and routed it all up. One thing I do recommend doing is, click on a drainage area here. So say when you first brought it in, maybe I'm going to look at I-11. Right-click on it. Look at the total area. It's 0.587. Okay, let's, not believing on Mark. You're thinking he's, yeah, it's all great. Let's see if our areas equal out, right? Free some of this stuff. I'm going to do an auto area. Click on area 11 and look at that. 0.5871. 0.587. It only goes to 3 decimal places. So area is equal. That's good, right? Okay. You need your pre and post to match drainage area for overall site. Just make sure your line works on top of each other. When you do your pre versus your post, and it will perfectly match. Trust me, I know it will. If it didn't, you did something wrong. I've done this so many times. Everybody else has too. It works, trust it. Now, if you're having problems, give me a call. You're probably, getting caught up here or there. The big point here is if I need to drain, so I get these all set up, this person is still grading this out. So these drainage areas are not necessarily complete. I might have to move them. If I have to update this file, all I do is delete these two overlay, these final two overlay, delete the post drainage area, recreate it, move the line work around, recreate it and overlay it. How long is that going to take? A minute? 2 minutes? Copy and paste the data into that worksheet. Oh, it closed itself. That's right. And if I redo the data, copy, paste it into here, and when I click this button this time, since the HydroCAD, it has all those nodes already, it updates them all for you automatically. So you just hit the button, and it will say HydroCAD. Here, I can actually do it. Close HydroCAD. So if I run this again, it runs through. You can see it's flashing, flashing. HydroCAD has been successfully updated. Of course, you have to have the HydroCAD file closed to do that, right? And that's it. Okay? So that's one piece. If you notice on these And that Excel sheet, whenever it runs, it always closes itself out. It's made to do that. When you open this a second time, you're always going to get this enable automatic refresh. Just do that. If you can see here, you sort of go through this way. You know, enter your soils, enter your drainage areas, update HydroCAD. We can also update HydroFlow. So, you know, management's one piece of the puzzle. What about conveyance? Well, I close down this file. Open up the storm file. Let me see if I have any questions here real quick. Okay, no questions so far.
Are you using the same drainage areas for
Yes.
the whole for inlets and ponds?
Because in the ponds, it's not the same drainage areas, but I'm using the same, you know, if you're using SCS, what you pretty much need to use to do MPDS, so I know we got a love with Rational, but you have to use SCS pretty much. You can just, you know, connect all these together and tell them to go to this pond. Now, you could do it separately, but that adds work. So you could do it, you could have two sets, one for drainage and then one for inlets. But if you do it in this fashion, the only thing that gets you down here is you have to connect these all. But quite frankly, this is a good thing because when I first set this up, I did not have this drainage area going to this pond or this drainage area. I had this drainage area coming over to here. And then I did my MPDS volume, and I noticed I didn't have enough draining to my pond. Well, I can simply do a quick, you know, back of the hand, is this going to work kind of thing? Say, well, what if I took this, you know, extended this inlet line that came out this way and drained it to this pond? Do I get, I can just see it, just like doing that. So there's a big advantage to setting up all your little sub-drainage areas. I noticed I needed even more. So what if I bring this channel? You know, this channel was originally bypassing, you know. So now I need to go back and update my numbers. Okay? Okay, in Civil 3D, somebody laid out the pipe system for me. It sort of gives itself a vertical design based on some rules. Pretty much equals what we have here. Then they went through and they, you know, moved up this pipe to avoid this sewer line and got a pretty good guess of how it's all going to be laid out. We're going to take that and we're going to put that right into HydroFlow. To do that, I'm going to right-click on the network in Civil 3D, hit Export to Land XML. It's going to, doing it that way, it'll select the right network for me. Hit OK. I'm going to export this, you know, right here to my Lunch and Learn, or you do this under the job number, and I export that to an XML. I already have a file there since I ran through this. Go into HydroFlow Storm Sewer Express, or extension, sorry. Go up to Input Output, hit Browse, select that XML. Before I do that, one thing you have to know about that is the names for when it exports that XML. If I show you, there's that XML file. If I right-click on it and hit Edit, we use in our topology names I-15, not I-15 space storm. When it exports XML, it always puts that name of the network behind it. So we got to get rid of that, right? So how hard is that? Well, all we have to do is find and replace space storm. Hit replace all, and it takes that name out, okay? And just save your XML. Hit open, answer your phone, throw Steve's phone out the window. Could you guys hit the button on that or something? Hit import, brings them all in. All right, this is fine and dandy, but still, if I hit data, it's all empty, right? I don't have the drainage areas. None of this is set up. So how can we get that set up? Well, let's just save this conveyance design. Sorry, I had it. Ran through this before. I'm just going to save this file. Save it. Close it. Go back to my worksheet and target where that is saved to and the file name. Note you got to put STM and hit update hydroflow file. It says rational data processed, hit OK. Hydroflow file has been successfully updated, hit OK again. So not only did I do a cover analysis, this method, for SCS, I also did it for rational, which is different coefficients. Open up my hydroflow file again. And click on one of these inlets now. There's your drainage area. There's your curve number. Any questions on that? For the entire system. In the email I sent out, I talked about the bigger the system, the better. Correct. I can save hours on a small project. I can save weeks on a mega project using this. So now all these inlets have all the drainage areas in them. I still have to go in here and design this. You know, I need to go in and set my cross slopes and down, you know, just like I had to do in HydroCAD. You still have to design. It's not like the computer. I don't have that. You need to work on that, Brandon. I need to hit a button. All right, so I already have this designed. I'm going to pull this across from my design set. And then that's 3D designed. Okay. So I'm going to put the design file up. I just had to do some file swapping there. All right, so now this is the design file. See how fast streamlining is? You guys just do that? Copy it from another directory, put it in another, it's all done. So I've set all my you know, pipe sizes and cross slopes and targeting down structures and, you know, all this information. Let's go back here and look at Civil 3D. So say Bob Boltozer was helping me out with this, and he said that, you know, he guessed that this is going to be a 15-inch pipe, and he's going to do 5%. Okay? Or the end invert, the very end invert for this inlet 9 is going to be 338. We'll say we actually design it, and that needs to be a little bit bigger. I'm going to click on it here, line 14, hit edit, and I'm going to go to pipe, and say we want to do an 18-inch. Well, let's do 24-inch. 24-inch, and we're going to set this to, oh yeah, 24. Yeah, that would probably not work that well. Don't do that. Probably won't import. 5. Okay, so I updated the upstream invert, so it's I9 to 335, and set the pipe size as 24-inch. I'm going to hit exit here, and say I do, you know, I do that system wide. You know, I design it. And you need to get that data back into AutoCAD, right? Because these profiles are already set up. Maybe you already had a 60% submission that you made. Well, now I need to update this. It's a lot of manual entry. Not really. You just come into Civil 3D. Sorry. Clicking too many places. Oh, yeah. Sorry. Yeah. Oof. Getting ahead of myself. If I want to take this data back into Civil 3D, I need to go to import or in-out. I'm going to go to export. Critical piece here is to hit update an existing XML. Click browse. Click the, I think I have everything right here. Yeah. Click, you know, I edited this, so I needed to use this design one. So you click the one you brought in. Hit open. Storm, and hit export. Now it's going to make a new file. So what's confusing there is that you think like you select this file, it should update that file, and then it prompts you to make a new one. You're like, what? I don't get it. Well, what it does is it reads the old file, and using that old information sort of categorizes the new file that it's going to make. Does that make sense? Yeah, you probably could overwrite it. And then it saves that new file, okay? So that new file saved out. Going to come up to Civil 3D, File, Import Land XML, back into Civil 3D, Start. That's what I named it. Hit Open, hit OK, and watch this pipe. Well, you're probably not going to. It's going to do a zoom extents, so you're not going to be able to see it. It's now a 24-inch pipe at 335, okay? Just updated by a simple import. So the larger the project, the better, right? Make a lot of changes. I even had this stuff all profiled, all done. I just have to hit plot again. That's all I need to do. So you can parallel task now, right? You don't need to wait till the storms is done before you can set the profiles up. Got it. Typically, if you needed to go back now into Civil 3D, you sort of couldn't. You know, what happened is when it brought that information back in, it sort of stripped off all the design that we placed on it. You know, we had to go in here and import and set up the cross slopes and everything for all these junctions. It sort of stripped that off. So you could never go into Civil 3D in the past, add in an entire new phase to this, and then go back into HydroFlow. It was sort of like a one round trip time, task. But not with the Brandon's Excel worksheets anymore. So say I make some adjustments here again. Let's say we're going to bump this pipe size up also to a 24. No, I can't do that. All right, okay. Pipe properties. Okay, so we made this between 10 and 12, a 24 inch as well. Going to save it. Going to export this. XML. So I right-clicked on in Prospector. Click the network. Export XML. Call this Start 2 maybe. Okay. So I made a new XML file. I'm going to open up or go to my R drive again. Go to Templates and go to HydroFlow. This is a different Excel spreadsheet. Now this one's more like a utility. You don't copy it and put it in your project. It stays there. It's like a program. Okay? So that just stays there. I'm going to open that up. Enable macros. And, the sheet sort of your guide. It says enter the path of the HydroFlow file. So that means the old design file. Okay? So the old design file is still at my Lunch and Learn directory here, my temporary Lunch and Learn directory. And then it's called conveyance.stm. Okay? Okay, go to step 2. Click this button. Got it. I can do that. Makes a backup of the file. And it says, click OK and proceed to step 3. Export XML Civil 3D. I already did that. All right, sort of did that first. Okay. Done. Got to remember, though, what do we have to do this file, this XML file? Anybody?
Find and replace.
Yeah, I did find and replace, right? So still got to do that again. So open it up, find and replace, space, STOM, space, place. No. Sorry. Place all. Thanks, guys. Save. Close it. All right, so I'm here. It says import the XML file into a new HydroFlow file. Save and close, overriding the previous version of the HydroFlow file. Well, that's sort of scary, right? Going to make a new file and save over the old one. Remember, in this step, it did a backup. So if anything goes wrong, you have that backup. Okay? So I'm going to do what it says. Go into HydroFlow again. Import, brand new file. Browse. Bring in this the second iteration. Yeah, maybe just big design changes, moved inlets around, did all this information. Hit OK. Hit open. Click on Storm. Select all the inlets. Hit import. Notice they're all blank again, right? They're not targeted, not in, don't know the cross slopes, don't know the drainage areas. It's like we're starting over. This is what we used to have to do if you made huge changes. You might have to start over if you thought that was the best way to tackle it. I'm going to save on top of my old file. Here's the backup. You can see the backup was put in this directory. I'm going to save on top of my old file. Close HydroFlow, and then click here to restore data. Go ahead and do that. It's going to ask me what data I want to restore. These boxes are pretty much checked by default. If you did want to, say you changed all your road cross slopes and you didn't want to restore cross slope, you can uncheck that. Does that make sense? So it doesn't restore everything. I want to restore everything though. Hit OK again here. Same thing here. You can uncheck certain things. Say you have known cues, but you know they're wrong, so you don't want to. You can uncheck things. Hit OK again. Please make sure all instances of HydroFlow are closed. Yep, I'm good there. HydroFlow data successfully restored. Hit close. And then let's go see what we have now. Open up HydroFlow again. Open that file. Now it's all restored, but notice this line now. This was 10. It's now 24 inch. So if I would have moved things around a lot, and it would all have been, so now I'm good to go. So you can round trip that data now as many times as you want. That's half a day right there. So you got half a day, You start adding all this stuff up. You're taking days to hours, and that's streamlining stormwater management. Is there any questions on that? There's one more thing I can cover, but I'm at 1 o'clock. There's another utility to, to get your MPDS worksheets and import the data into those. And I'll show that here just in a minute, but since it is 1, I'll open up with any questions. All right, is there any questions on the phone anybody had? Does it import the structure type? No. Well, yeah. What do you mean, Jason? When you take this information back, Jason Lutz asked, does it import the structure type? When you take the information from Civil 3D into HydroFlow, no, it doesn't. They're all manholes. Sometimes, depending on the structures, it will designate if they're inlets or manholes, but most of the time you have to set it up. But you just have to set it up once. Once you set it up once, you use that utility to round trip the data, and Brandon's worksheet does, I churn these all from manholes into generic grates or whatnot, and it brought that back across. Any other questions? All right, this MPDS worksheet thing is just going to take maybe 10 minutes to show you. So if you want to hang out for that, if not, you can jet. Close down all this Civil 3D stuff. I don't think I needed it all, actually. Okay. So to do the MPDS worksheets, I'm sort of going to just show you how to do it. Maybe not exactly go through it, but it's using this the same HydroCAD HydroFlow worksheet. So if I open this up, it's this one. We went through here. We did soils. We did the data importing. We did the update HydroCAD, update HydroFlow, but we didn't use this button yet, right? Okay. Well, if you notice down here, we populated this. This is our drainage areas, but we still have this data. What's this? Well, what we'll do here is create a topology for the entire site. I'm not going to go through all the overlay, but this topology right here that's called MPDS, how did I know what to call that? How do you think I knew what to name that? It's on the worksheet. I want to do an MPDS overlay, figure out my entire site cover types. Here's the overlay instructions for that, making the work and making the topologies. You can see it's a real simple topology. It's the site. It's just one area with a node in the center that says site. And then it's a bunch of overlays. It takes literally 30 seconds to create. Make sense? Because it's just one area. Now, if you're doing your MPDS volumes and breaking it up in your site, maybe like this side of the site drains to like one creek and this side drains to another creek, maybe you put a line down the middle. You have two. You do your overlay information right here. We're going to overlay it for soils, then we're going to overlay it for pre and post. Okay. We're going to copy that data into our worksheet. So let me browse to the project I did this on. So I made two folders, post MPDS and pre MPDS. Okay? You have to do that. I copied that worksheet, that HydroCAD HydroFlow worksheet, same one. There's only two worksheets in all this, just two. The one for the round tripping of the pipes and then the one for the areas. I pasted it in here. I opened that one up. This is an older version. If you have old versions, you'll get a message we have it, so if we make new edits to it, you'll know. I had to set the soils for the entire site, so I have a couple more. And then I pasted the data for the site. See where it says Site 1? And it did the overlay analysis, so it's the covers and everything. Okay? Paste it all into one column. A lot of area. Essentially it. I hit this button, Update MPDS Worksheets. What it does for me, close some of this information, is it makes this folder at the same level that this worksheet's stored at, and it makes an Excel file in there called Site 1. Okay? You open up that Excel file. That has all your drainage areas and cover types and curve numbers for the entire site. So if I add all this column up here, my total site area is 68.65 acres. That's something you need on your MPDS permit, right? There you go. You got it. Better yet, go back to our handy-dandy R drive. Go one level up from the topologies and go to MPDS. And there's a worksheet in there called MPDS Worksheets. This is the worksheets you have to fill out for MPDS permits, right? The real pain in the patoot to fill these out. Copy that, paste it in your project directory, right? Paste it in your project. I come into here, and this is where I want my pre and my post development area covers. It adds them up and it figures out my volume, right? So it does all the math over here. Well, if I have this open, at the same time I have this site sheet open, like have them open in Excel at the same time, I can go from my MPDS area, hit equals, switch over to my Site 1, tag Meadow. I'm going to do the same thing for the second row. Tag Waterways. And there's a little trick in Excel, if you take these dollar signs out of the front of both of these, you can highlight the rows, press Control and hit R, and it will, what do they call that, the copyright or whatever. It brings it to the, it brings it over to the right. Since the dollar signs are no longer there, when it did that, it changed this to B, changed this to C2, so you're getting the data. Same thing here, filled right. Control right is fill right. Look at that, fill down. And you can see, I have to add some rows. Okay. There's where my data ends. All right, well, there's my pre-area and my pre-volume. All right? So I do my post. What's the big point with this? So then, you get your volume. Now you know what volume you need to infiltrate, okay? Does that make sense? Is everybody with me on that? I know I didn't go through everything on that one. I can see it here if I go back to my actual site or my actual project. I have that worksheet copied in. I can open it up. I have all the data there, and then it tells me my volume I need to infiltrate in acre feet, right? You start doing your reductions. The big key here is, how easy is this to update? It's extremely easy. I don't even have to do this referencing, since this is linked to that worksheet. You say, well, my NPDES permit boundary never changes. Well, never say never, first on that one. And secondary, yeah, but your cover does. You add a road, you move roads around, you add houses, you subtract houses, your post-cover changes. And I know it's a lot of effort to update that. And I bet you if we add houses, we don't update it because it's too much effort. But I'm sure if we take roads out, we do, right? Because we want the credit. Yeah. So doing it the right way, you just run those topologies, a couple minutes, paste the data in, hit update worksheets. I go back to here. I paste the data back into these two Excel files, hit the button, it updates this sheet, which since my NPDES calc sheet is linked to that, it automatically updates that. Next time I open it, it's right. So that investment up front can really give you a lot of gain on the backside when you have to update stuff. And since Stormwater is so iterative, it's important that we streamline that process for our updates. With that, does anybody have any questions? Those are the things I wanted to go through. All right, well, thanks everybody for attending. Again, this has been recorded, so I know it's a lot of information, but when you're saving that much time, it's a lot of things that you need to show. And this recording will be available on our intranet site for you to view and take a look at in the future. Thanks, everybody.
Thanks, Mark.